Okay, next up, we're about halfway through the Noah Petro show. For this talk, Noah himself will be talking about sampling fragments of the lunar interior, pyroclastics as a key to lunar evolution. Go ahead, Noah.
Thanks, Sarah. I also want to thank Marie Henderson, who just joined us at Goddard as a postdoc, for help with these slides. Next slide, please. So one of the things that we haven't really featured in this session, apart from the presentation you'll see from Tim about Aristarchus, is what are the value of going to pyroclastic deposits. And so we propose 4 potential landing sites, some on the near side, some on the far side, and some on the western limb, that would provide insight into the deep interior of the moon, as well as the possibility of volatiles derived from the lunar interior. Of course, we know that there's a range of pyroclastics across the surface of the moon. Some were sampled at all the Apollo landing sites, most famously, of course, Apollo 17. But if we can go to some of these more unique features and constrain mantle compositional variation in situ, that would, of course, be a very valuable thing. As Clive said, of course, all of this is precursor. We want the samples back in the lab. No one's supposed to talk about in situ sample analysis, but the ultimate goal has to be getting some of these fragments back into our labs on the Earth. Next slide, please. So, we know that sampling of volcanic glasses is important. Artemis SDT calls that out multiple places. We know from orbit that there are a number of these really interesting features across the moon. We want to understand, where did these glasses come from, how much volatiles might be found inside the glasses, and what is the relative fraction of glasses versus quenched materials in these deposits. If we visit multiple of these features, we get to see, again, varieties in formation, mode of emplacement, as well as compositional differences. Next slide, please. So first, let's talk about one of my favorite pyroclastic deposits, the Oriental, the so-called KISS. It's a ring feature about 75 kilometers in radius from a central vent. Has a very distinct compositional source, this intermediate position between the Procalarium Cape terrain and the Felspathic Highlands terrain. It's unlike any other pyroclastic we see on the surface of the moon. At right is a quote olivine feature map from Kaguya, but of course it also highlights the spectral signature of glass, and so we can identify exactly where to go. And I take Robert's point from earlier to heart about precision in our awareness. But there's a number of potentially really excellent landing sites within this feature that we could target. Next slide, please. Sinus Hgm is a really unique pyroclastic feature. Carly will talk a little later on about spinels on the surface. This is a iron or chrome spinel pyroclastic deposit. We see no other similar compositions elsewhere on the moon. And so targeting this would obviously reveal a very interesting part of the lunar mantle expressed at the lunar surface. I call into, as a particular target, the so-called beacon crater. We have a NAC DTM of it. It would be a compelling target for sure. Next slide, please. This was the area of my introduction to lunar science back in 2000, Oppenheimer. It's a crater on the far side of the moon in the South Polacan Basin. It's a floor-fractured crater with several localized pyroclastic deposits. Not only would we be able to sample mantle material from underneath SPA, but of course the possibility of trapped volatiles, as well as obviously addressing SPA science, would be compelling here. Next slide, please. And lastly, Lavoisier on the northwestern hemisphere of the moon, near Oceanus Procellarum. Again, another unique feature and different mantle source from the other visited pyroclasts. Next slide, please. So with these, we obviously want to get the material, want to scoop into the regolith or drill, ingest the material, look at it with spectrometers at the surface, and get bulk composition of the glass through any number of mechanisms to complement the remote sensing data. Next slide, please. Enhancing capability, we want to go and drill into this to look at potentially variations as a function of eruption. So whether or not there's lateral variations if we have a rover, or vertical variations in how the material erupted on the surface. But again, we're all aiming towards getting these materials back as a real enhancing capability. I've lost the clock on the screen, so I'll just wrap up there. Thank you.
Okay, thank you.